Obviously that should move. Sweet. When I first started videotaping my lectures, at one time I put my water bottle right in front of the camera, and the whole thing is like seen through the. It's like an MC Escher type thing, which makes statistics more interesting. So hopefully everybody is here for the same reason, Math 3D for science students. How many of you guys are astronomy? How many of you guys are like physical sciences or physics? A few of you guys. Earth sciences, geology, geography. What else could we have? Chemistry. Biology. Physiology. Yeah? Okay. It covers most everything. So we all have very different needs. So I need you to be honest with me as we go through this, because if there's something that we all collectively feel is okay, we want to get to the harder stuff, you have to be honest. If you don't think it's okay, you want some more stuff, you just say, yeah, let's go over this a little bit more, and if you don't want to do it, just sit there and wait. All right? So this is really about getting everybody what they're here for, is the help that they need for their own specific course. At the end, like I was saying earlier, if you have more specific stuff, somebody was saying they want to see how to graph in Excel and stuff like that, or if you have more specific stuff that I didn't hit, then we could do that towards the end. Okay. Just make sure you get that sign-up sheet before you head out. Doing okay? Yeah. So the very first thing that we talk about, and just give you an overview of what we're going to talk about, we start with building up into scientific notation. So some basic exponents into scientific notation, because a lot of the courses, astronomy, you talk about distances between stars. You normally use scientific notation to denote that, or different, light years. Even then, you still need scientific notation, possibly. Then we're going to get into significant figures. Has anybody hit significant figures at all? A few of you guys? All right. You don't like it so much that you don't even want to admit.
Yeah.
So I've got like 2 rules that'll keep you through the whole thing. Then we're going to do a little bit of unit conversion. I know my chemistry people. Chemistry is almost all unit conversions, right? Moles and grams and all this stuff. A tiny little algebra review, and then some graphing, and then that'll lead up into the we can do some Excel graphing at the very end if you need to see it. Anything else that you want to talk about? We talk about at the end. If there's anything I don't go over enough, just ask more questions that you've seen in class if you have something specific. All right, so here we go. And every now and again, unfortunately, they still haven't put page numbers in this thing. So we are going to stop every now and again. I'm not going to just talk the whole time, thank God. There's little sections where you can do work, and then all the answers to those sections are on the last page. So you can kind of check yourself as you go. All right. So we're going to start really basic. Just be honest with me about how it's going. I think I always get at least 1 or 2 people that have some trouble specifically with some stuff with exponents. Normally, stuff like this is pretty simple. What would that be? X and I. So right now, some people are like, oh, this is not what I need. We're going to start really basic, then we're going to get much more advanced, so don't freak out. I'm going to cover the whole gambit. What does this mean here? Beautiful, because the negative power tells you to flip, right? Not a big deal. So you can see how all the properties of exponents come from the fact that the way it's defined. And it's because math people are lazy or frugal with their time, whichever way you like better. So we don't like to write, oh my God. So somebody said 2, 4, 6. He just called everybody up and said, dude, if I put a 6 up there, that means X in a row 6 times. Because this guy over here had already done, of course. He'd already come up with this. He stole that, jerk. So then we had to put the 6 up there to mean multiplication. So all the properties of exponents come from that. This leads up naturally into scientific notation. And once you write things in terms of exponents, you have to know how exponents interact to be able to work with them. So the very first place is, what is scientific notation? So if I had 4,000 I can write that as 4 times 1,000. 1,000 I can write as 10 to the third power. Personally, and I still do, but especially when I was younger, I had trouble with left and right. I still have to do this as I'm driving, as somebody's giving me directions. The one that makes a real L is left. You with me? Give me a break, right? I got all this math crap in my head. I need room somewhere. So I just decided not to know what left and right is. So I always hated it when they said, when you have a positive power, you move it to the left. It screwed me up all the time. And it makes more sense to think a positive power means a big number. Because a positive power is truly multiplying. And negative power would be something like this. Because that would be, what is that as a fraction? 4 over 1,000? Yeah. Which is 4 over 10 cubed. That's not scientific notation. I've got to force that up. And if I force that up, this rule kind of takes into effect. Those 3 10s want to be down. If I force them up, they're going to tell me I want to be down there. So I always thought negative power, not left and right, negative means small. Negative means a small number because the negative power is dividing. Cool, how we all do it. So definitely do me this favor. If this is all very old news and you're just biding your time until they get the harder stuff, great. If this is not old news and I'm going a little too fast, you got to slow me down, or else I'm just going to kind of keep going. Okay, cool. So how do I have them interact with each other? If I had that, what would happen?
First coefficients and multiply them.
Yeah, cool. So it's a lot like 2x to the 6, 4x to the negative 12. I do my coefficients. 2 times 4 is 8. What do I do with those powers?
6
minus 12.
6 minus 12. Beautiful, right? So here's a little curveball, and then I'll do my first time here when I shut up finally. Here's a little curveball. What if I had, what do you got, Jeff? I don't know. And the answer must be in scientific notation. I got to remember to stay within that, guys.
I don't think it's Kevin.
I know. I just got to stick it here. I just forgot. So what do you guys think? The first step is not hard. That's not where the trick comes in. Yeah, so you get 8 times 4 is 32. 10 to the negative 52. Now the mistake, if you left it like that, you're not right, because is that scientific notation? Scientific notation sucks all the 10s out of something. That's really what it does. And 32 still has a 10 in it. If that decimal is not right after a single digit, you're not right. So now how do you adjust this? Yeah, now it's a question. I know I want it to be 3.2, but what does that do to this? So think about this. Which way does that want the decimal to go? It's right here right now. Which way does that want it to go? Negative power means make it small, so it wants to move it to the left. Negative power means make it small. Cool. So it wants to go that way. So if I move it one way for it, how many places does this have to go now? It had to go 52. I moved back 1. Now it only has to go 51. So that's one way to do it. Or, very quickly, is everybody with me? See, the first step is simple. But this step now, everybody cool with the first step? You can ask that. So 8 times 4 is 32. And then what do you do with powers when you multiply? You add them. So negative 12 plus negative 40 is negative 52. How are we doing? This is where I need you to be honest. I don't want to steamroll anybody. Yes, ma'am?
Okay, how come you didn't add the 6 and the 12 on the top when you subtracted it?
I totally added them. What's 6 plus negative 12?
Okay.
Cool. I'm with you. That's exactly what I need.
Okay.
Don't let me steamroll you. And it could be just, it could be a mistake on my part. Who knows? That's okay. So now from here to here. Yes, sir?
Okay, I got all the numbers correct, except I made a positive 52. I thought 2 negatives make a positive.
Only when you multiply them.
Okay.
If I'm adding, if I owe somebody
Right,
12
okay.
bucks and I owe somebody else 40 bucks,
Yeah.
I wish I could make my debt disappear, but I still owe 52 bucks, still negative. How we doing? All right. So now, one way you can adjust this. The only problem with this answer, I've done all the math correct. The problem is the question said the answer's got to be in scientific notation and the decimal's in the wrong place. I can't just put it there and leave that the same. That's not the same number anymore. You with me? So the decimal is right here. This wants it to move that way. So if I move it that way once, this guy only needs it to move 51 more times. So that's one quick way to kind of do it. That's the way I actually do it. The other way, if you don't like that way, the other way is leave this part alone. How do I write 32 itself in scientific notation? I got to move the decimal once, so it's 3.2 times 10 to the first. I only had to move it once, right? And now what do I do with these exponents? Add them. 1 plus negative 52. Negative 51, the same thing I got that way, right? Either way works. Okay, cool. So just in case you use scientific notation in your classes, if you don't, great. All right. Now you know how to do it if it ever comes up. Okay, so let me do this. Let me shut up here for a little bit. On the 1.4, see the 1.4 exercise problems? 1.4 exercises? Do a couple of those. Do number 1 and 4. And then on the next page, 1.6 exercises. Do number 2 and 4.
So
You can do more if you want to, but just do those.
1 and 4 on the example.
Yep. Cool. The answers are all in the back. Do you need one of these? Yeah.
Let me see what 60.
So you can check yourself as you go. Call me over if you need some help. This will give me a chance to help you directly if you don't want to, if you feel uncomfortable speaking up in general. I can pause you. How are we doing out there? Doing okay? So 1.4, the thing to be careful about, like on number 4, it's still got to be a negative answer, right? So don't lose that negative sign. The power also has to be negative. And the way I would think about it is because it started off small. So it's got to be a negative power. And 1.6 number 2 is like that last one we did. You've got to be careful. Your first step doesn't quite get it there. It's not quite in scientific notation yet. Okay. So on 1.6, real quick, number 2. Oh yeah, red's not the greatest. When you do this first step, you get 36 times 10 to the
34. Bounce over.
10 to the 5th, yep. And of course, how do you adjust that? Because the answer is not quite in scientific notation, the decimal's in the wrong place. And the one way to do it is to realize he wants it to move that way, make it big. So if I move it against the poor little dude, he's got to now go
1 over.
6 more. Because he wanted to go 5 from here that way. If I move it back 1, he's got to move 6 in that direction. He's like,
so we
damn.
added.
The other way to do it is 36 is 3.6 times 10 to the first,
And we added.
times 10 to the fifth. 1 and 5 makes 6. Same answer. So either way you like doing it works. Thank God. Okay, cool. And number 4, I gave you a division problem. 3 divided by 2 is 1.5. Now, what happens here?
That's where we're going to do it.
Good. It's not 6. There's 2 ways to look at this. The rule is subtract. So what's
Right.
8 minus -2 is 8 plus 2. The better way to look at it, to tell you honestly, is those guys want to go up there anyway.
That's where it's
You got two tens coming up. You had 8 tens. How many total tens do you have now? 10
It's
tens.
2.
Right. How do you guys feel about that? Because the negative power means flip.
That's
He's
right.
going to go up. Now they're going to have 10 of them up there. So times 10 to the 10th.
So it's a result.
Or you can think about it, if I divide by a small number, my answer should get bigger than it used to be. And times 10 to the negative power is a small number. The answer should get bigger. Is that cool? Is that all right? I got a mixture of emotions looking at me right now. Some of you guys I don't want to play poker with. Just continue. All right. Okay. So unless there's any more specific questions, or again, don't let me steamroll you. If you got questions, we can stick with something. Okay. Very often, if you're using a scientific calculator and you see this, does anybody know what that means?
1.7 times 10.
Beautiful. That's your times 10 to the, right? So this would be 1.7 times 10 to the 10th. On a scientific calculator, it probably would look like this and have a little 10 up there. Some of them even have like a times 10 to the, it shows up like that. So it all depends on what your calculator is set up to do. So if you're not sure anything about your calculator that we do today, you can certainly ask me when we stop or ask me at the end. Cool. I promised that I would say a little something about percentages. I promised some of the science teachers. Because percentages, and I've seen it in my math classes, fewer and fewer people seem to have a good understanding of percentages. I don't know why. So if I had 22 oxygen molecules and 487 total molecules, what percentage of them are oxygen molecules? Got to be careful now. 22 are oxygen out of, and that tells you, thank you, that tells you exactly how to set it up. 22 out of 487. If it was 22 out of 100 total, this is the symbol for oxygen, it's not 220, sorry. 22 out of 47, so you divide those. And it's just, it makes me sad when I see how few people really kind of get that as compared to a few years ago. I don't know what's going on in high school, but when you do 22 divided by 47, you get
4.52%.
I like it. Cool. Yeah, is that cool? So percentages are definitely going to show up. I keep going back to chemistry, because chemistry is basically science math, if you really get down to it. But it shows up in other courses too, obviously, percentages of things. Hopefully everybody gets a basic understanding of percentages. So let's get into Sig Figs. What actually mathematicians call Sig Digs, significant digits. So if I say that, please allow me, because I'm a math person. But significant figures, the idea is actually a really good idea. I don't want to have to write a paragraph to somebody explaining how certain I am about a measurement I've taken. There's got to be a quicker way to say it to somebody. So here's the idea. If I measure something and I get this, this is let's say this is Team A, and I got these people up in the Antarctic, and they're taking ice samples, ice cores, and they're measuring the whatever the hell. And one team got 0.3, and then Team B, they got 0.30. Mathematically, math says, what? These are the same stupid numbers. Science says one of them is more certain about what they saw than the other one. Of course, I mean, even if you've never seen Sig Figs before, you should be able to kind of guess which one seems to be saying that they're more sure about what they saw. Yeah, Team B. So this one is somehow more certain. It's got a higher significance. Significance. That's too late to spell right. There's a time window in a day where you can spell correctly. All right, so that's the basic idea. So now we need a way to kind of measure this, so we can compare things less abstractly. I want to compare things with some numbers. So I don't know if you guys, how many guys remind me? How many guys want to admit that you've talked about Sig Figs already? There were just a few guys.
Yes, in chemistry we
In our
have.
classes?
Yes, in your classes.
Yes.
Maybe even in your just general life, which normally doesn't show up that much, but maybe it does. So, when I was taught this way back when I first took chemistry, we were taught like 5 rules, and then the 0 was important sometimes, and so that it gets a little messed
Is
up.
that the leading 0 that they talk about in our
Yes,
class?
so let me show you a way to cut through all the stuff. Here's just 2 rules you need. You ready? To know how many Sig Figs something has. If the number has a decimal, stay with me. All right, if the number has a decimal, then you start counting at the first non-zero all the way to the end. So our examples up here, they both have decimals, so I can do Sig Figs for both of these. 0.3, what's the first non-zero number?
3.
And where's the end?
3.
Good, so how many Sig Figs does it have? 1. So this is 1 Sig Fig. 0.30, first non-zero to the end, 2 Sig Figs. There you go. So now that's a way to measure. It's a way to quantify. Yes, it is more certain. You can see there they got 2 Sig Figs and they only got 1.
How come they don't tell us that?
I don't know. They should have. I don't know. Why don't they tell us that? They might have, and it just got mixed in with everything else. So what if it doesn't have a decimal? If no decimal, it's a whole number. Start counting at the first non-zero again. It's kind of silly, but I'm just going to say it that way anyway. First non-zero, stop at last non-zero. Thankfully, it's all written in here because my writing is bad, if you haven't noticed yet. So, for example, if I had 40,120, how many Sig Figs? 4. Good. So Sig Figs here, 4. I mean, that's simple then, right? So I think of this as like bookends, right? The first non-zero, the last non-zero. You just count those and in between. You kind of with me? Okay. Cool. So those of you who have done Sig Figs, does that make sense? Does that kind of jive with what you've been told?
Something in the text, there's a small little part in it where it does say that, but the decimal and then after or
Okay.
anything between.
But see, normally the rules say 0 here is important. This
Yeah,
doesn't say anything about that.
They say the
Notice,
leading 0.
and after doing the rule, you'll realize that 0 is not important. That 0 is just a placeholder. And if you think about it, that 0 really depends on what system of measurement I pick. If I choose kilometers versus hectometers, then the decimal would change. That should not affect the Sig Figs, though. I want to be more significant. Let me use inches. What the hell? That didn't make any sense. Do you guys kind of follow me? I mean, just because I move the decimal shouldn't suddenly make it more significant. So that 0 doesn't matter. It's just a placeholder. Now, there is one place where it's a little unfair. And I'll show you a way out of it. And it actually kind of explains some of this a little bit in a different way too. If I measure something, if I measure how long something is, I found a giant squid, and I measure one of its tentacles, and I swear to God, I'm measuring, I got the calipers out, I got everything going, and I get exactly freaking 3,000 centimeters. That's not really fair. I mean, I was just measuring the hell out of this thing. It just happened to be exactly 3,000. Maybe it's 3,000.0002 or something. I'm not going to get that. Shit. So I get 3,000 centimeters. That's not really fair because how many Sig Figs? That's not fair. If it would have actually been 2,999, somehow I would have suddenly had 4 times as many Sig Figs. That doesn't make any. That's not fair. So how do you take care of that? How do you write that in scientific notation? 1, 2, 3 to the third, right? But you just include, now how many Sig Figs? It's got a decimal, so what do? Start the first guy to the end. Now how many Sig Figs? 4. Now it's fair. You with me? So there is inherent in this kind of a unfairness. If you do happen to get exactly this, that's not fair. So just write it as a scientific. You can do the same thing over here. This as scientific notation would be 4.012 times 10 to the 1, 2, 3, 4. If you meant for that 0 at the end to be part of it, then you can put the 0 at the end. You give yourself one more Sig Fig, so you're being more honest. You guys kind of with me? A little bit. Not at all. Shit. Let's do this. Say again? Yeah, you would. If I put that versus this, they're both the same number mathematically, but that has 1, 2, 3, 4, 5. Because now with a decimal, I count all the way to the end. You guys still with me a little bit? All right, some of you guys look ready to sleep. So let's do this. On page, right after this first Sig Fig page, right at the top, do all 6 of those. Just identifying how many Sig Figs. Then we're going to talk about what if you start multiplying and adding these things. How do you tell how to write the answer? All right, so what about number 1? 3. It's got a decimal. You start at the 1, you end at the 5, you get 3. 2.
4.
Decimal, it's got one more 0 at the end. You don't care the 0, just go to the end. So you get 4 Sig Figs when you count. Number 3.
4.
Beautiful, because you start at the 1. You start at the first non-zero. So you notice how those 2 zeros after the decimal are not significant? Do you have to actually memorize that or know that? No. You start at the first non-zero to the end when it's a decimal. So you still get 4 Sig Figs. Number 3 and number 2, if you wrote them in scientific notation, they would look the same, except the power on the 10 would be different, right? And they both have 4 Sig Figs. That makes sense. Number 4. Beautiful. You start at the 1, you stop at the 5, because there is no decimal. Start at the first non-zero, end at the last non-zero. Beautiful. So it's only got 3 Sig Figs. Number 5. Good. Start at the 1, end at the 5 again. And number 6. 6, beautiful. It's got a decimal. Start at the 1, and way down at the 5 at the end. Get 6 Sig Figs. How are we doing there? We doing okay? I'm trying to read your faces.
So when there's a decimal and then zeros, we count right after the
So
non-zeros.
don't even bring zeros. When there's a
Just-
decimal,
right.
you start at the first non-zero number all the way to the end. If there's no decimal, if it's a whole number, you start at the first non-zero, end at the last non-zero. The book ends.
Right, so number 3 has 4 significant figures, right?
I love it.
Number 4?
Number 4.
I mean,
I'm sorry.
3.
3's got 4 Sig Figs.
Okay.
Good. And 4's got 3 Sig Figs. I like it. Yes.
So would you say that no matter decimal or not, you always start at the first non-zero?
Yeah, basically. The thing they both have in common is start at the first non-zero. The funky thing is, if it doesn't have a decimal, obviously the first is going to be a non-zero. So you can say you start at the first number, but you guys with me?
Yes.
Does it really matter? No. Good. All right. The weird thing about this, now that's semi-decently easy. Just figuring out how many Sig Figs something has. Now, once you start multiplying and dividing, you still have to give your answers honestly. So in a sense, when you multiply a bunch of numbers together, measurements, or divide them, your answer should be like almost the weakest link should rule the day. Whatever you're most uncertain about should rule what your answer is. So you're honest to everybody that overall we're not very sure because there's one piece we're not sure about at all. You guys kind of with me? So the weakest part should rule the day. So when you divide or multiply, so for example, if I had 4.027 times 13.1. Step one is just do it. Put in the calculator. I don't think your teacher's going to make you do long multiplication. Just do it in the calculator, get an answer. And then step two is round it to the correct place. Don't try to do both at once. That gets crazy. So when you multiply those, somebody help me out.
Yeah. It's 52.7537.
Cool. Now, how many sig figs does this guy have? Good. Decimals count 4 sig figs. This guy has 3. So my answer should have 3 to match the weakest part. Right? You all are the weakest link.
So then we only go to 52.7?
Yeah, so now you identify. Now here's the key part.
Oh,
Here's the part that gives
number.
people trouble, and you're okay. This actually
Yeah.
is fine. I want 3
Because
sig
those are
figs, so I want to go out to this place. But now you have to actually round it. So the sig fig tells you how far to go in. So you know where to go, and now you got to truly round it correctly. So now what do you get? 11. How are we doing about that? Is that cool? Same thing with division. So that's kind of awesome. You just multiply and divide like normal, and then at the end you just look who's got the least sig figs. I'm going to make my answer have that many sig figs. The least sig figs. There's a tongue twister in there somewhere. So what if I had, I don't know. And there are some calculators up here if you need them. So it's 0.078 or something.
It's 0.07761.
Math guy, I got to show off every now and then. That's all I can do.
I was going to say the same thing, but then since it's the smaller one is 4.
Yeah, so I'm not there yet. I was just trying to figure out close to what the answer was. Now you come back to your sig figs. This is how many sig figs? Careful. 6. So it's got a decimal. You go all the way to the end when you count. So 6 sig figs. This has only 1 little sig fig. So my answer has to have 1. So I have to go out to here. So that'll be 0.08. Bam. I got 1 sig fig at the end. So that communicates to people that we were really sure about that number. But then we multiplied it by a number that we're not sure at all about. So my answer has to convey that. Are we doing so far? Is that? So it's all about being honest with what you see. It's really what science has done. Science has got to be all about being transparent and honest, or else people are going to just, we're not going to read any more stuff from you. You lie. So we got to be transparent and honest, and that's how we do it. So what about adding and subtracting? That's going to be a little bit different. And I'll try to show you why. I turn the do back on. Okay. Let's see if I can come up with an example. Let's say I have measured something to be 1,000 inches, and I add, we can even make it more interesting, 499 inches. So I got 1499. Now, if we try to use the same rules we just did, my answer would have to have how many sig figs? How many sig figs does he have? 1, right? whole number, start at the first non-zero, end at the last non. Oh shit, that's the same place. So you get one sig fig for him. He's got 3, but the weakest is him. My answer would have to have 1. It'd go right back to 1,000. Do you guys see that? 1 sig fig. That's not above 5. So do you see how that just does not make a damn bit of sense? I can't take 1,000 and add 49 and get 1,000. Then you do it again. Add another 49. It's still 1,000. Right? So somewhere this guy is using sig figs wrong to give somebody raises, and he's like, "You're going to stay at 1,000 for the rest of your life? That's evil. Give me some more money." Right? So there's got to be different rules than that. There's got to be something else that controls this. And of course, what controls things when I try to set things up to add? When I involve the kind of numbers we normally see, which aren't always whole numbers. What kind of sets things up? So if I had to add 1.08 plus 99.297 plus 125.4. What's going to rule the day when I try to set it up? If somebody was evil and making me do this by hand. The decimal place. So that's kind of a nice way to remember. The decimal place is what rules the day here. My answer has to have the same number of decimal places as the one that has the least. That still is conveying a measure of how certain I am about something. But it's not going to allow for this kind of evilness here. You guys kind of follow? So who has the least decimal places here? Yeah, this only has 1 decimal place. So what do you get when you add these all up? Somebody help me out?
225.777.
I like it. 225.777. I did that on purpose. So how many decimal places does my answer have? 1. Again, ruled by the weakest one. He's only got 1 place. My answer then can only have 1 place. 225 point. Beautiful, because that's 7. I like it. So it still conveys information about the weakest part, but that rule here would be just not fair. That would not be a fair rule. So that's why we come up with this other rule, ruled by the decimal place. How do you guys feel about that?
Well, wouldn't it be 1.08, the smallest?
How many decimal places?
There's
2.
Oh, that's
So
right.
who's had the least decimal places?
Of the decimal.
Yeah, just the decimal places, the number of decimal places. Is that cool? Okay, so let's try that. And again, definitely calling me over. Now this is the page with a ton of problems. Right before section 3.0 there. So let's just do a few of these. The 2, 3, and 2, 4. Do number, let's do 1, 4, 6, and 8. You can do more if you get early. Get done early. When you add and subtract, when you sig figs really become a play. That's all. Sig figs really become a play. He's got 3. So he had Okay. This would be 10 to the negative 1. Because the funky thing is it's missing to that 1. So I think you're moving 10. It's actually like an understood 1. Okay. So real quick, let's take a look here. I put a little bit of work up here. Like on number 1, it's 3 places, 2 places, 1 place. So that 1 place rules the day. So when you're adding, subtracting, you just look at decimal places. You really don't care about Sig Figs, truly. So I want my answer to have 1 place. So when you add them all up, what do you get before you round?
Which one?
1147.061.
Yeah.
And then if you want to get to 1 decimal place, so it'll be 1147.1. Now, if that would have been like a 4, would you just do that? Good. You still have to do that. You guys with me? Now, it wasn't that, so don't freak out. So it would just be that. But just in case, you would have to show that was 0, because then it's showing that 1 decimal place. It's still information about how sure we are about what we see. On number 4, I only wrote one thing down. The very first number has no decimal places. I think that's the big loser here, right? That's the weakest part, no matter what the hell the other guys are doing. So when you add them up before you round, what do you get?
128.879. Oh, I'm sorry, 120. Yeah.
128.871?
79.
0.79?
879.
And then, so you need no places now, so you need to go here. And so you look at this guy, so this becomes 129. So if you have no places in one of your things in an addition subtraction problem, your answer has to be a whole number. That's all there is, yeah. So really, this whole thing about Sig Figs and all this, and getting the right format for your answer, that's the last step. It really doesn't come in until the end. You do your normal stuff, you do all the algebra and the math and all that kind of stuff, and then at the very end you come in with, okay, where do I need to round to? Number 6, the top number has how many Sig Figs? 4. Right, because it's a decimal, so you got to start at the 5 and go all the way to the end. You get 4 Sig
number
Figs.
6? Are you number 6? Okay.
On the bottom, how many Sig Figs? 5.
Yeah.
So my answer has to have how many Sig Figs? 4. Good. The weakest one is 4. So I'm dividing, so it's all about Sig Figs now. Adding, subtracting is all about decimal place. So when you divide that before you round, what do you get?
116.22231. 116.
116? Okay, sounds about right. 0.22231? Okay. And so you told me I need to have 4 Sig Figs. It's the weakest one. So 1, 2, 3. I need to round to here.
So it's
116.2. Good, because that's not big enough to make a 3. Sweet.
Okay, that would make 100%.
Does that look like stuff you've done in class, a few of you guys?
Yes.
Of course, the rest of you are, who knows? It might come up, it might not. Number 8, for some reason it freaks people out, number 8. That's sort of the math behind the scenes, so you are multiplying.
Right.
How many Sig Figs do they each have? 2 Sig Figs each of them, right? So your answer has to have 2 Sig Figs. So you get like, what, 30.937 or whatever?
Yeah.
So you need 2 Sig Figs. So you got to round to this place. 36, cool. That's 2 Sig Figs.
Okay.
So it's real easy to get too confused. You could be going to yourself, but the decimal places don't matter when you multiply and dividing. Sig Figs matters. Sig Figs don't matter with anything when you're adding, subtracting. Decimal place matters.
So we're multiplying, dividing the Sig Figs.
Sig Figs rule today. When you add,
Sig Figs.
subtracting, decimal place. Exactly like what would help you set the problem up. What rules the day there rules the day here. The decimal place. Cool. So, Any of those specific questions about Sig Figs that it didn't hit? Like, how likely is it that I'll see these, Jeff? They look weird. All right. So let's get into what I think might hit home for more people is units and unit conversions, stuff like that. Okay. Let me first start off with a discussion about metric system. And I'm going to talk about the main ones. You guys will probably add in some other ones. If you're in chemistry or astronomy, you might already have added in stuff like picometer or femtometer or angstrom, even if you're talking about wavelengths of light, which is certain times 10 to the whatever millimeters of light.
I think it's -12.
Certain number of nanometers.
Yeah.
So let's first talk a little bit about the metric system, which of course screws everybody up here in America, because America is one of, I think, 2 or 3 countries on the face of the earth that don't use metric.
We just like to be different.
Yeah, we like to use the system that actually is truly based on measurements of a king of England from the 1600s or whatever. That is what we use. Do you realize that? If you didn't realize that, there you go. Right? What happened? We had the whole Revolutionary War and all that kind of shit. We still use those measurements. What the hell? Oh, well, too bad for us. One of our spacecraft smashed into Mars because of a misunderstanding about metric versus feet and inches. Did you guys know that? And I can't remember if it was Pathfinder or Mars Orbiter. I can't remember now which one it was, but one group used metric, and then for some reason Americans thought it was in inches or something, and so they, okay, it's approaching Mars. It should do, bam! Oh, it's what? What's happened? It smashed up because they thought they were further away than they really were. That's oh good. You don't believe me? Google it.
Our teacher just told us that NASA only uses metric now.
Oh hell yeah!
Yeah, they switched.
They should have. I mean, that is the language of science. Metric. I mean, we have a crazy system. 3 feet in a yard, 12 inches in a foot. How many freaking pints are in a gallon? I have no idea. Shit. I like to cook. I don't know. Tablespoons? Don't even bring that into play. But metric, it's all based on 10. Why? Because our freaking number system is based on 10. Probably because we have 10 fingers. That's the thought. If we had 8 fingers, we'd have a number system based on 8. You know, that would look like take my 120 someday. Math 120. I teach different bases. Metric, we normally know, the biggest one we normally use is kilometer. And then there's 2 other ones here. Then there's meter. And there's one here. And then there's the 2 that we normally know. The centimeter and the millimeter. And then some of you guys should be going down from there. Nanometer, picometer, maybe femtometer, depending on how tiny. There's just tinier and tinier and tinier. When you're measuring wavelengths of light and you're measuring, you know, distances between electrons or whatever, you're going to be getting pretty damn tiny numbers. Let's fill in the blanks here real quick. What are these here? Anybody know?
Hectometer.
Good. Hectometer.
Yeah, hectometer and then decameter.
I like it. Decameter. So this is hecto, deca. And here, this is like a whole number in a way. You with me? 3 meters. And so this would be like right after the decimal. So that's the decimeter. Because this is 1/10 of a meter. This is 1/100th. We all know that that's 100 centi. 1/100th of a meter, 1,000th of a meter. You guys with me? Okay, and of course this is 10 meters, 100 meters, and kilo is 1,000 or something, kilometers. Kilograms, and you're watching some CSI, and they talk about kilo of drugs. That's what they're talking about, 1,000 grams of whatever. Okay, so here's the beautiful thing about metric. Every step you take is a factor of 10. So if I have, what do you got, Jeff? 787.2 decimeters. And I want to know how many hectometers that is. Every step I take is a factor of 10. And when I go from small to big, I need to make my number smaller. If I have 787 decimeters, that's not very many at all hectometers. Right? Because these are huge. It takes a lot of these just to make one of these. So watch the beauty of this. Every step is a step of 10, so that's really just moving the decimal, and I actually move it the same number of times in the same frickin' direction. You can't beat that for conversions. So compare that to converting liters to cups or something. Hello, that's disgusting as hell. Right? Or even gallons, whatever. But this is beautiful. I mean, you just got to move the decimal 1, 2, 3 places back. 1, 2, 3.
That's what I was thinking when I was going through tutors, as we were going the opposite way for being it, you know, a big giant number. That's what I was doing once we did that. What is it called? The map. It's a map equation that we follow going backwards. You know, finding the common.
Okay.
We're using that.
We'll do that too.
And I was watching that. It was just adding zeros by the power of each.
Exactly.
And I was like, that's what
There's
I
gotta
keep
be a
seeing.
shorter way.
Yeah, I keep saying that to myself. There has to be a shorter way.
There it is. Because if I have if I have 2 kilometers, well, every kilometer is 10 of these, and every one of these is 10 of these. So that's why it makes sense if I go in that direction, my number should get bigger.
Right.
2 kilometers, 20 of these, 200 of these. So that exactly matches up with just move the decimal that way. So 2 kilometers would be how many meters? 1, 2, 3. 1, 2, 3. I add 3 zeros on. Just move the decimal over that way 3 times. It's crazy. And here's a real quick thing. I don't know if this is really going to help anybody out. But if I knew how to write this down, then it's easy to step around and convert in metric. And I don't know if you ever heard, have you heard this? King Henry died Monday drinking chocolate milk. It's true. No. King Henry died Monday drinking chocolate milk. The one bad part about that, if you want to use it as a mnemonic device, is it's not just meters that could go here. What else could go here?
Millimeter? No.
So that's the measurement of length. What's the measurement of volume in metric? It's the one metric thing we have in the U.S. because we get 2 liters of
Milligrams.
Coke. So liters.
Oh, liters. Oh.
Right? We get 2 liters of soda, right? Or 3,
Yeah.
if you really want it. And for weight, of course, it would be grams. So you can have
Grams.
kilogram, hectogram, decagram. You can have deciliter,
Right.
centiliter, all that. So that's the beauty of the metric system. It said, why do all this feet and cups and teaspoons and shit? Let's just use the same standard prefix. And then we can step around it the same way. All right, cool. So let's go to more general conversions. Does anybody know how many centimeters in an inch?
2.54.
11. Cool. So 2.54 centimeters in an inch. So let me show you. Now some of you guys have no trouble with this at all. That's awesome. Because really when you're converting numbers, it's all about knowing when to multiply and when to
I
divide.
just learned this on Friday.
That's the key thing. If I have 82.7 inches and I want to know how many centimeters that is. Now if you know how to do it directly, that's great. Just hold on. Let me just show you how to do any conversion problem. This is a very simple one we're starting with. We'll do a much more complicated one next. I'm at 82.7 inches. I've noticed some people hate this for some reason, and if you do, I'm sorry. This is the best way to do this, really. Unless you show me a different way and I like it, I'll start teaching that way. The beauty of this is I don't have to know when to multiply or divide. I just need to look at my units. I want my inches to go away, and I want to replace them with centimeters. So where would I go inches so that they'll cancel? On the bottom. See, they cancel them. So what's the truth about these? How many of these in this?
That per each inch.
2.54 of these
Is it one?
is one of these. So I'm multiplying this number by 1 effectively because this is the same as that. You with me?
Okay, you're doing it.
Kind of with me.
Yes.
Not with me at all. Shit. So it's I was going to say that. These are the same thing. 2.54 centimeters is 1 inch. So if I divide by an inch, that makes the inches go away.
Right.
And then I multiply by 2.54 centimeters, I've actually not done anything. It's still the same length. I've just changed the units. I got rid of those units, and I'm going to replace it with those units are now still alive. Right? So what do you when you multiply those?
210.058.
And then you can bring in a question of Sig Figs. The thing about, real quick, conversions have infinite significance. That sounds like a good band name. We got infinite significance. I think so. conversion, I don't know if you've heard this before, those of you who have done Sig Figs. Conversion numbers have infinite significance. Therefore, they never come into play to tell what to control. It's always your own measurement that controls the day. You with me? So how many Sig Figs does this guy have? Which happens to be the same as that, but look at it. So I got 3 Sig Figs here. My answer better have.
3.
And so I need 1, 2, 3.
You draw.
Now here's the evil part, right? So what should it be?
2.10.
210. Why is that evil? How many Sig Figs does that look like it has?
Only 2.
Looks like it only has 2. But I can't do this, because then it would have 4. So the only thing I really can do is this.
Oh, yeah, that's
So I'm not sure what your teacher would say. You guys still kind of with me? That was a little technicality that I didn't know was going to happen, but it just did.
So is that the proper way to write it out then?
Yeah, that's really the only way you can be explicit. Because now how many Sig Figs? There's a decimal, so it's 1, 2, 3. You count all the way to the end. So now it has 3 Sig Figs like it's supposed to. If you just leave 210, that looks like 2 Sig Figs. That's no good. Now I've left off one thing that your science teacher would cry. What have I left off here that's really important? The units. What units? Centimeters. And so would your math teacher, for that matter, if it was a word problem. I put 80 what bananas? All right, let's try a more difficult one. Then I'll let you guys try a few out on your own. Let's see. How many feet in a mile? This is not the problem, by the way. It's just the setup. 5,000? 280?
Yeah, that's right.
So 5,280 feet in a mile. All right, so here's what I want you to do. So let's see. And how many, do you guys know how many kilometers in a mile? You ever notice you look at your speedometer, it's always a higher number. In fact, I went to Canada, and I was driving around Canada right before a friend's wedding. They live up in Seattle. I was driving around in Canada, and when I went over the border, it was so freaky when I hit the first speed limit sign, because 30 kilometers is actually a decent speed. But when you come over, when you look at 30 kilometers is kind of slow. Let me go the other way around. 30 miles then is a decent speed. But when I came across the border and I saw 30 miles an hour, I'm thinking, 30, holy shit. Because 30 kilometers, let's do a little easy one, is how many miles? So what would I put here?
Miles.
Kilometers.
I mean, oh yeah.
You with me? Because then the kilometers will cancel.
Yeah, that was right.
So then you can fill in, it's 1.6 kilometers in a mile. So what's 30 divided by 1.6?
18.75.
Yeah, 18.75. So, and don't worry about Sig Figs. So basically, when I saw that sign saying 30 miles an hour, my brain thought it meant around this. And I'm thinking, I'm not going to go that slow. Because I hadn't transitioned from freaking Canadian kilometers, because you see it all the time. When you first go to Canada, you feel like you're just flying, because you're going 120 kilometers an hour down the road. It's not really crazy fast even. 100, if I was going, that's great, you could do it. So let's say this. Let's say I have 8.29 inches of material costs 72 cents. I want to know how much it is feet per dollar. Or let's do, let's make it crazy. Miles per dollar. So let me, this is a little more complicated one. But the same basic principle applies. You do not worry about the fact that there's a unit on the top and the bottom. The idea is to kill what you don't want there and replace it with what you do want there. So you always start with what you know. I know that it's 8.29 inches for 72 cents. Now which one do you want to attack first? I've got to make that into miles, and I've got to make that into dollars. Inches. Okay, so where would I put the inches? On the bottom. And where can I go from? Now here's the part that people always skip. We're going to go from inches. I want to eventually get to miles. So, of course, what's the middleman?